Hey everybody, how you all doing? Welcome back. We got another video for you. Before we get too far, we're going to start with a little review. So a couple weeks ago, we talked about what to do in this situation. If you have two bases that are the same and they're being multiplied, you're going to add these exponents. Here, 3 plus 5 would equal 8. So this is x to the 8th. When you don't have bases that are the same, you can't do anything to the exponents. So this would stay x to the 3rd, h to the 4th. Can't simplify that at all. When you have a power of a power, what you're going to do here is multiply these. 5 times 3 is 15, so this would be x to the 15th. And in this situation right here, if there is no exponent on one of your variables, you can always put a 1 there. And what I'm going to do is I'm going to treat this like distributive property. I'm going to multiply this by each of the exponents inside here. So 2 times 1 is 2, so I have h to the 2nd power. And 2 times 3 is 6, so I have x to the 3rd power. All right, so for today's lesson, we're going to talk about numbers, negatives, and fractions. The easiest way for me to explain this to you is with an example. So here we go. So suppose we had pi times 2xy squared, all that squared. This is how we would do it. First of all, the pi is outside of these parentheses. The only thing that's actually being squared is all the stuff in the parentheses. So I'm just going to write that pi there for now. Now, for all the stuff inside the parentheses, if there's no exponent here, assume that there's a 1. 2 times 1 is 2, so I have 2 to the 2nd power. Same thing for the x. If there's no exponent, assume it's a 1. 2 times 1 is 2, so I have x to the 2nd power. Here, y to the 2nd squared. 2 times 2 is 4, so I get y to the 4th. Now, what I'm going to do is I'm going to simplify where I can. This 2 to the 2nd power, we can do this. We know that 2 to the 2nd power is going to be 2 times 2, which equals 4. So I'm going to write that down. Now, when you're simplifying these, if you have a number, the numbers always precede everything else. So the numbers go first. Then you can put all your letters and symbols. So I'm going to write 4. I took care of that. I've got the pi here, so I'm going to write pi. Next, I've got an x squared. I'll write that. And then I've got y to the 4th. And I am done. Not so bad, right? Okay, so now we're going to start talking about negatives. And interestingly enough, to teach you negatives, first I'm going to talk about positives. If you have a positive number or variable with an exponent, the result's always going to be positive. So let's look at the ones because they're the easiest things to multiply. Here I have 1 times 1, which equals 1. 1 times 1 times 1, there's 3 of them, equals 1. 1 times 1 times 1 times 1, there's 4 of them, equals 1, and so forth. It doesn't matter how many times you multiply a positive number by itself, it always gives you a positive answer. But the negatives are a little bit different and they follow a pattern. Let's take a look. So here, again, I used the number 1, but this time I made it negative. So I have negative 1 squared, negative 1 cubed, negative 1 to the 4th, and negative 1 to the 5th. And I'm going to write out what they look like as a multiplication problem. So here, I have negative 1 times negative 1, and a negative times a negative is a positive. Here, I have 3 of them. Negative 1 times negative 1 times negative 1. Now, a negative times a negative is a positive, and a positive times a negative is a negative. So the answer is going to be negative 1. And let me go through that one more time in case you didn't get it. So I have negative 1 to the 3rd power. This 3 tells me that I have this base 3 times in a multiplication problem. So when you multiply the first 2 of these, a negative times a negative equals a positive. So this becomes positive 1 times, and then I have this one here as well, negative 1. And now when signs are different and I multiply, it equals a negative. That's why we get this result right here. Now, let's look at the exponent 4. So now I have 4 of them. And let's see what happens. Negative times negative is a positive, and then a positive times a negative is a negative, and a negative times a negative is a positive. So this is positive 1. For the last one, and I'll write it on this line here, I have 5 of them. 1, 2, 3, 4, 5. So again, let's go through this. Negative times negative is a positive. Positive times a negative is a negative. Negative times a negative is a positive. And a positive times a negative is a negative. So this would equal negative 1. So look at the pattern that we have here. Positive, negative, positive, negative. What do you think 1 to the 6th would be? If you said positive, you're right. It just follows that alternating pattern. Positive, negative, positive, negative. So what's the difference? Well, when you have a negative number here, look at the exponents. Even, odd, even, odd, even, odd, and so forth. If you have a negative number and it has an even exponent, the answer is positive. Negative number and an odd exponent, the answer is negative, and so forth. I'll put up some problems here to show you. Okay, so here's 4 problems here. Again, I'm using 1 just because it's a super easy number to multiply. So the question is, when I take these negative 1s and I have them to these powers, is the answer going to be positive 1 or negative 1? Well, again, we need to look at the exponent. So here, the exponent's even, so it's going to be positive 1. Here, the exponent's even, so it's going to be positive 1. The number 3, that's an odd number, so it's going to be negative 1. Here, the exponent is 297. That's an odd number, so the answer is negative 1. All right, so let's see this with some numbers that are not 1. So here I've got negative 2 to the 3rd power. So for now, just ignore the negatives. I've got 2 to the 3rd power. Well, 2 times 2 is going to be 4, times 2 again is going to be 8. So I know it's going to be an 8. The question is it positive or negative? Well, is that an even exponent? No. So it's going to be negative. If you want to verify that, if I was multiplying these negative 2's, negative times negative is a positive, and a positive times a negative is a negative. So it checks. Now let's take a look at this one. Negative 3 to the 4th power. So again, ignore the negative sign for now and just concentrate on 3 to the 4th power. So 3 times 3 would be 9. 9 times 3 is 27. 27 times 3, 81. So the question is it going to be negative 81 or positive? Well, look at the exponent. It's even. Since it's even, it's going to be a positive number. Let's verify it. Negative times negative is a positive, so those two make a positive. Multiply it by this third one, positive times negative is a negative, and multiply it by the last one, negative times negative is a positive. So it verifies, it checks. Okay, so here we are with the last part, fractions. Now, with fractions, it's not that bad. Just think of fractions like 2 problems in 1. Both the numerator and denominator, you're going to use the exponent on. For example, let's say I had 2/3 and I had this squared. Well, remember, if there's no exponent on something, assume it's a 1. So I can put a little 1 there and a little 1 there. 1 times 2 is 2, so this is going to be 2 to the 2nd power. And 1 times 2 is 2, so this is going to be 3 to the 2nd power. 2 to the 2nd power would equal 4. 3 to the 2nd power would equal 9. So 2/3 squared would equal 4/9. All right, so let's see if you really have that. Let's look at this problem right here. Is this one making anybody cringe in their seats? It's really not that bad. So we've got a fraction, and this fraction is being multiplied by h to the 5th. The whole entire thing is to the 3rd power. Take it piece by piece, or part by part. So first, let's take a look at the numerator here. What do I do with this 4 and 3? I multiply them. 4 times 3 is 12. So this is going to be x to the 12th power for this fraction here. Now, for the denominator, for the numerator, pardon me, for the denominator here, if there's no exponent, I put a 1. 1 times 3 is 3. So now I have negative 2 to the 3rd power. And then right here, for h to the 5th, 3 times 5, 15. So now we can actually simplify this just a little bit more. There's nothing that I can really do with the numerator, so I'm just going to leave that there, x to the 12th. The denominator, however, though, I can do this. 2 to the 3rd power. Well, 2 times 2 times 2 would equal 8. So I know the denominator is going to be 8, but there's a negative sign here. So is this going to be a negative 8 or a positive 8? Well, is that odd or even? It's odd. So that means it's going to be negative 8. If it was even, it would have been positive 8. And the h to the 15th, just leave it there. And we're done. That's it. So if you understand all of this, you should be pretty set. Hopefully it wasn't too complicated. Hopefully that made a lot of sense. If you have any questions, don't be shy. Hit me up. I'm here to help. Hope you all enjoyed the video.